Welcome to FNet Silica's We Talk IoT. We'll chat with innovators, experts and business owners to learn how they are implementing IoT and using data to create new business opportunities. I am your host, Stephanie Ruth Hayden. In today's episode, we are concluding our special series on the Advanced Electronics Challenge with the winners themselves. Joining me today are Johannes Büker, CEO, and Paul Werner, CTO of Hydronauten. Their innovative solution addresses one of the most overlooked energy consumers in both industrial and residential settings: pumps, which remarkably, as I've learned from you, account for approximately 30% of the EU's electricity consumption. But through intelligent data analysis and AI implementation, Hydronauten has developed a system that optimizes pump operations, thereby significantly reducing energy costs while at the same time contributing to grid stability. So I'm really excited to learn more about the solution. Welcome to the show, Johannes and Paul, and congratulations on your win.
Yeah, thank you very much.
Before we dive into the technical details, could you both briefly introduce yourselves and tell us what led you to found Hydronauten?
Yeah, great. Thank you very much for the short introduction. My name is Johannes Büker. I'm the CEO of Hydronauten or Hydronauten. We are a small company in Germany, in the north of Germany, near to the Baltic Sea. And we are experts in active vibration damping for pipelines and pumps. And that was the reason why we founded the Hydronauten company. The first goal was to reduce the vibration and the air and fluid-borne noise in pipelines. And after that, the technology rise up to a very high level of technology to control the whole systems. We are founded in 2022, and there we start to get bigger and bigger and solve the problems and our customers.
Mm-hmm. Wonderful.
I was not there at the beginning by the Hydronauten. I was a student when I met Johannes at the university, and this is when he started with this topic about noise cancelling and grid stability. And he hooked me completely, actually. And then I started my master's thesis about this topic, and after that my PhD. And by this time, Johannes had founded the Hydronauten company, and I joined 1 year later, basically.
Paul was there at the beginning from the first step. He was there, and he was the whole time involved in the development.
Nice. So you won the Advanced Electronics Challenge. Congratulations. We've already had the other participants also on the show, so I will link the other episode in the show notes for our listeners to listen, to enjoy the whole series. Could you explain now what your winning solution does and what problems it addresses?
So what our system basically does is, like your noise cancelling headphones, reduce noises and by that also vibrations inside pumping systems, or especially in pumps and the connected piping systems. And what maybe sounds a bit like a first world problem, or the pump so loud, is in larger industry applications quite a problem, because many pumps, especially those in wastewater treatment, are quite large and powerful, and they produce not only what they also produce a lot of vibrations. And when those vibrations are not controlled correctly or kept under a certain level, they will damage the whole surrounding system. So the pipes, the pumps itself, and the surrounding buildings. And if those pumps are close to residential buildings, they will annoy the residents, of course. And you can, by applying the active noise cancelling, so introducing additional noise to counteract the noise from the pumps, you can eliminate most of that vibration and thereby, for one, reduce the impact on all surrounding infrastructure. This was the main goal when we started, to reduce vibrations and noise. And the advantage that introduced itself by reducing the noise and vibration was that you actually cannot control many pumps because of that noise and vibration in speed. So many pumps are set to a certain speed or to a certain power level to reduce vibrations or not to work at a certain point of operation that will introduce a lot of noise. And thereby those pumps are running quite inefficiently. And this is just normal, so it's what you do basically. But as you said, pumps do consume a lot of energy all around the world. We cannot live without pumps. From the morning toilet up to hygiene, hospitals, everybody uses pumps, industry of course. This is a lot of impact in terms of energy consumption. And when you hear that those pumps are running not very efficiently, this is a big problem. And we can, by reducing the noise and vibration, also control the pumps in a very efficient manner, because we do not have to counteract, or we have not look for problems in vibrations or certain speed regimes where the pumps will destroy themselves. So this gives us a whole new opportunity to control and run those pumps.
The main topic is that we help our customers to improve their operational safety on one side. That is the vibration problem and the whole noise problems. And on the other side, we reduce the energy consumption. And to reduce the energy consumption, it is necessary to reduce these pressure pulsations, so-called pressure pulsations. And the technology, we called it the quiet hydro technology, is the enabler for this controlling method.
Okay. So in simple terms, and of course without telling us your secret, but how does your technology work? How do you make pumps quieter?
So it's like, you can imagine like a noise cancelling headphone. There's a big speaker, or there's a speaker for one that is introduced into the pipework. So it's actually connecting with the fluid, for example, and like an underwater speaker. And we sense the noises from the pump with a sensor or with a pressure transducer, and calculate in real time basically a cancelling signal or a counteracting signal that is then played back by the loudspeaker. And that is overlapping with the sound of the pump, and by destructive interference, they cancel each other out. This is basically the same principle like in your noise cancelling headphones. Okay. Basically, it's an old technique. The first papers you will find on that topic are quite old. They are from the mid 20th century. Wow. The basic concept is quite old. But doing this in hydraulics or in a water pumping system, for example, is not as easy as your noise cancelling headphones, because the range and the speed of sound in water, for example, or in fluids, is quite a lot higher than in air, for example. And this makes it quite hard to do and to calculate those cancelling signals. And for that we need quite strong signal processing. And this is basically what introduced us to the Advanced Electronics Challenge. We started with self-built, self-taught signal processing systems and noise cancelling algorithm. And in cooperation with that challenge, and we have also to say with our electrical engineer here at our company, he brought our signal analysis system to a whole new level with those components. And this is now, for one, much stronger, and for the other hand, much more efficient and smaller than it was before. So basically the brains of our system is what was part of the Advanced Electronics Challenge and what brought us here.
You mentioned sensors and data. Can you share some insights into how AI specifically comes into play or what data you are collecting and analyzing?
So this is maybe quite a sensitive topic. I will try to steer myself around some pitfalls. The main algorithm that is playing the noise cancelling basically is a very simple, AI, you could say. This is if you cut an AI to its complete basics, you can use that for noise cancelling actually.
Mm-hmm.
So the other way around, you could say our noise cancelling algorithm is basically a very, very toned down AI.
Mm-hmm.
But this is not this is doing the noise cancelling, but this is not what gives us the opportunity or the ability to reduce the energy consumption. What we do with that is we collect a lot of process data about our noise cancelling. And with that data, we can see how efficient the pump is running, basically. So by using the sensor data and by using the noise cancelling data, we can quite precisely hear, or you should say, the best efficiency point of the pump, and also how the whole system is running. If there's maybe damage to the bearings, or if the pump is running at a good operation point or not, we can hear or see that. And we trained an actual AI or a neural network to learn the pump operation and to optimize it.
Mm-hmm.
And by that, we saw that we can save up to 20-30% of energy consumption of some systems.
Terrific. Okay.
So there are basically two intelligent systems. For one, the noise cancelling. For the other one, the optimization algorithm that's collecting data from the noise cancelling and optimizing the pump speed.
Mm-hmm. Your solution also works with existing pumps, but also with new installations.
You can introduce our system into existing systems. We usually need about a meter or 50 centimeters of space inside the pipeline at the discharge line of the pump.
Mm-hmm.
There's enough space for that. And our system is much smaller than any passive system that is capable of reducing those levels of noise reduction that we are able to. And for us, it's also much easier to build a new system for an existing pump, because we can measure how loud that pump currently is in the current system, and we can fine-tune our quiet hydro system to that. But we can also build those systems for new installations, because then you can plan the small part of the pipe for our system, and it's easier for us to install it.
Mm-hmm.
So it's just plug and play. Basically, all the sensors and all the installation is done by us or by people of our company, and we're tuning the system after that, maybe for a few hours, and then it's up and running and doing its job basically for its own. It's completely autark, you could say.
You mentioned that you're optimizing the pumps itself and that you're also protecting them or keeping them safe from breakage due to the vibrations and energy savings. Are there any other benefits your customers are experiencing?
The great consumption of the electronic consumption of the pumps makes the pumps able to use it for stabilization of the electronic grid, of the electronic power grid.
Mm-hmm.
If you produce more electronic power than you use in the electronic grid, then you get a problem. Or if you produce less electronic power than you use, then you get a problem. And on both sides, you have to control directly the balance between the producer and the consumption.
Mm-hmm.
And you can use pumps for that. That was the starting project. It's called smart grid controlling. So if you have more electronic power in the electronic grid, then you can rise up the pump speed a little bit,
Mm-hmm.
or you can slow down the pumps a little bit.
Mm-hmm.
And we can see how exactly the balance on the electronic grid is about the 50 hertz that we have in our electronic grid. And for example, 1 month ago or so, we had this problem in Spain and Portugal.
Mm-hmm.
There was a problem between the consumption and the production of the electronic power. And therefore you can use pumps because you have so much pumps in the electronic grid for this stabilization.
Okay.
Yeah.
That's
It's
I was just,
another USP of our technology. Yeah.
yeah, I was just going to say this sounds like an oddly familiar problem that went through the news a couple of weeks ago when Spain, Portugal, and I think part of southern France's complete grid shut down, right?
Mhm.
So you say this could have been easily prevented by pumps?
Yeah.
Okay.
That was the conclusion of the research on the university where we met each other, Paul and I. There we started, but at this time there was no big problem in the grid because there are many big power plants with the wind turbines and solar panels, and so there is a big fluctuation in the power grid. And this fluctuation we can stabilize by pumps, for example. And yeah, in the future we want to do this with big pumps and with small pumps.
Incredible. Have all the European governments knocked on your door yet?
At the moment we are not known from them. Yeah.
Okay.
So we have to make some more marketing and more
Okay.
go out and yeah.
Yeah. Let's see if we can change that.
Yeah.
This problem, and just maybe because not every one of our listeners is familiar with how the energy system and the smart grid works. The adoption of renewable energy causes grids to become a little bit more unstable because there are high peaks of high production of power, and then there's not enough consumers that take the power out of the grid again. So it kind of peaks and then collapses.
That's correct.
Okay.
You have to make sure that you have 50 hertz in the grid. And if you have more energy in the grid, then the frequency rises up. And if you have more consumption, then the frequency goes down. And every step leads to a not stable process in the electronic grid. That is the problem in the electronic grid. Because we have not enough batteries and we have not enough capacity to
compensate for it.
To compensate it. Yeah.
Oh, okay.
Yeah.
Interesting. Yeah, and probably a provocative question. Why is that? Because we are probably just not there yet? Or is that something that just didn't come to mind?
I think it's probably not yet. It's not there yet.
Oh, okay.
Because we have the
Hydroelectric power plants,
yeah.
for example, because those have a lot of capacity to save potential energy.
Okay.
So pumped hydro is a correct word for it. If you pump a lot of water up the hill, and you store a lot of potential energy that you can use later if you need a lot of energy. And this is, in quotation marks, quite easy because it's just water on a higher level. So, of course, you need the infrastructure for it. But the controlling process is not as complicated by the concept. But introducing smart systems like bigger consumers, for example, cooling warehouses use a lot of energy, and those have sometimes contracts with the electricity producers to for a short moment shut down their cooling processes because this will not have a big impact on their warehouses, for example, but it will buffer some of the demand in the energy grid, and thereby it can dampen the effect of the rising and falling frequency in the grid. And by introducing pumps to that system, there's a lot of potential to manage that grid frequency. but it is not known that you can do it. And also because, and this is maybe the loop back to our noise cancelling, when you control the speed of a pump very roughly or very fast, to stabilize the grid, you will introduce a lot more pressure pulsations than you had before. Or maybe you will encounter speeds where you get resonances with the pipework, and this is why you, before our technology, would just not do it, because it would introduce much more stress and more damages, for example, in the systems. But with our noise cancelling, you are actually now able to use pumps for grid stabilization. So this gives this like a handshake, basically. You need the one technology to use the other.
Okay, terrific. I understand that you are you still in a startup phase, or can you already share a specific customer success story that demonstrates the real world impact of your solution?
It's a wastewater pumping station on the Baltic Sea here in Greifswald. It's a city in the north of Germany, on the Baltic Sea. And there is a pumping station where you have got vibrations in the whole surrounding of the pumping station. These vibrations causes vibrations in the living rooms of the people in the buildings around. And so they don't control their pump very efficient, and they have big problems with destructive problems on the pipe work. And there we installed 2 of our systems. There are 5 pumps, and 2 pumps are running all the time. And we installed 2 systems, and 2.5 years ago. And since that, they have no more problems. They have no more people that are shouting about these problems. They deal with that now for 12 years, and they didn't find any solution. And they are totally happy now. There we installed the quiet hydro control unit for the pumps. We will see in a half year we have better data grounding to know how many energy consumption we can save there. But at the moment it seems that there are 20-25% they are saving energy. And that is the field. That is not only experimental or so on. That is the field on the outside. Yeah. And they are very, very happy. Yeah.
I can imagine, thinking about my living room shaking every time someone...
But you need these pumps and the pumping stations mostly in the middle of the city, because the wastewater goes down there in the city. So you are not able to move this pumping station to another location where the vibrations don't affect anyone or
that would make me even
surrounding.
More unhappy as a person who lives there, I guess.
Yeah. Definitely.
You have to think about not only the pumping station itself, but also the connecting pipework, of course, because all the sewers are connecting to a collection, the pool, basically, where the pumps are then pumping the wastewater to the next wastewater treatment plant. And also those discharge lines go through the city to the next treatment plant. And you also had to dig up those pipes and lay them anywhere else. It's not that easy.
Coming back to the Advanced Electronics Challenge, what was the most valuable feedback for you or insight you gained during the competition process?
It was how compact and how small you could do those signal conditioning and signal processing. Before we had large modules to do the signal processing, it was quite complicated. It was a lot of work to change anything, basically. We rested on one solution that just worked, but were not able to iterate on it. And with the integrated circuits and stuff like that, we are now able to much finer control those processes and integrate those much smaller and more compact in our system. And that also makes it easier to build those closer to our actual hardware systems. Before we had to do it all in big enclosures with a lot of energy.
Normally we have a big cabinet at the moment, but now we can reduce this whole electronic hardware to a smaller one, and that is on one side it's great for our product. On the other side, we must be the benefit for the company. You must go to a product, not only to a special solution. And these steps are small, but with these modules from the challenge, we have now a way to do this and to make it to a real product, to a real case of products, smaller and bigger systems. That is the biggest benefit of the challenge.
Were there any particular challenges or pivotal moments that pushed you to innovate even further?
The way we can now program our algorithms is enabling us to do much more iterations, to be much more faster with our iterations, and thereby to develop much better and much more effective solutions. For example, there's the additional signal processing needed for our AI system that is doing the pump optimization. That had to be a complicated system stacked on top of it, and now we can integrate it much more easily and iterate on that. And this makes us much faster in development.
Is there anything I have forgotten to ask you that you wish I had asked you?
We have possibility to make a predictive maintenance or condition monitoring on our system for the customers with the new circuits from AFNet. We are able to do this in our own cloud or to do this in a leading system at our customers. And that makes it able to see many faults and many problems in every pumping station before it comes to a catastrophe.
One big part of the AI understanding of the pumping system, we can see when something is changing and what is changing, and by knowing how and what is changing, we can also say, okay, maybe it's a bearing, maybe it's a problem in the discharge line, for example, or there's blockage or something. And we can not only see it, but we can, of course, tell the customer, or the system tells the customer itself by terms of IoT or any system like that, either directly connected to their PLC or through our cloud.
If you had to put together a soundtrack for this episode or your project or your solution, what song would you put on it?
We have found a soundtrack, it's called The Pump Action.
Oh.
I know a version of The Observer, the group is called.
And that concludes our conversation with Johannes and Paul from Hydronauten. Thank you for sharing your insights today. Your innovative approach to pump efficiency optimization demonstrates exactly why we created this podcast, to highlight how IoT and smart technologies and data can address critical challenges while delivering tangible business benefits. So thank you for listening to We Talk IoT. Until next time, stay curious and keep innovating.